Okay. So what we are going to start with, is a practice quiz for Tuesday. Now, there's a lot of complaining, but you know what? Some of you really need the points. And let's face it, the quizzes we've taken have been easy. This one is going to be easy too. Okay? What we're going to be quizzed over is the law of cosines work that we talked about last time. So let's pay real close attention and get through this practice work, and then we'll quiz on Tuesday. Now, this sheet has 2 sets of practice, okay? 2. I am only going to right now do the front side, and then if we have time after we finish up our notes, we'll come back and do side 2. But we're all working on side 1. Everybody there? Everybody's got your calculator all ready to go? And we are going to solve for C. Now, this is a little bit different than the quiz you just took. Because on the quiz you just took, you had to solve for everything. Right? And here I'm asking you to only solve for C, which is right here. Now, solve for C. That means you're going to use the law of sines or the law of cosines. Okay? What do we have to have if we're going to use the law of sines? If we're going to use the law of sines, what do we have to have? We got to have a partner pair, right? Somebody called it partners the other day. I love that. You got to have a partner pair right here. Do I have it anywhere? No. So if I don't have a partner set, I need to use the law of cosines. And the law of cosines is the one that says, okay, whatever angle you're going to use, which in this case is going to be 53 because it's the only one I have, goes over here. And then there's a bunch of stuff that equals sine, and if you put 53 as your angle, then you're going to put c squared over here. Would you agree with me? That's how it works. Now, what's going to go in the middle here? Exactly. 10 squared, not 12, 10 squared. 10 squared plus 14 squared.
Are these you? From a copier?
No.
Who would that?
Marianne. Is that her handwriting?
I'll take those.
Okay. 10 squared plus 14 squared minus 2 times 10 times 14. Oh. Hey, Jen?
Hey.
Okay, so let's talk about that one more time. We have 10 squared plus 14 squared minus 2, 10, 14 cosine 53. Everybody remember that? Now, the nice thing about this is that there's no messing around to do. You get to just type it straight in. So 10 squared plus 14 squared minus 2 times 10 times 14 times cosine 53 equals. Now, did you get a big number?
Yeah.
Like 127?
Yeah.
Remember, that is not your answer. That is c squared.
Square root it.
So we need to square root it. So we're going to square root that number. And I got c to be 11.29.
And you can put it in a calculator when it's a variable at the beginning?
Yes.
Okay.
All right, so everybody got 11.29 for that? Now, when we did these in our notes, ahead and found everything else. On this quiz, you do not have to. You're finding side C, and then you're done with the problem. Okay? All right, now the next two talk about area. So the last time we were together, we talked about two new ways of finding area. One is Hero's formula. And you remember that's the one with the big radical? And when do we use Hero's formula? When we know all three sides, which is exactly what we know. So our area is going to be this big radical. And under the radical is four things. Does anybody remember what the four things are that go under there? Katie?
It's like 1/2, side, or sine of the angle.
Okay, that's what I use when I have an angle.
It's
Okay.
sine,
It's like semi-perimeter.
and then
So I need the semi-perimeter, and remember the semi-perimeter
And then
is
A, B, C.
half the perimeter. So what's my perimeter? Add them all up, you got a calculator. What is it?
26.
So, well, the perimeter is 52, which means the semi-perimeter is 26. So that's the first thing under the radical is the semi-perimeter. Then we take that number minus each side. Remember that?
yeah.
So that's going to be, and order doesn't matter. So 26 minus 10, 26, oh not, no, I'm sorry, I'm on the wrong problem. 26 minus 14, what is that, 12? 26 minus 18, and 26 minus 20. And then we just times them all together and take the square root. So 26 times 12 times 8 times 6 square rooted, I got 122.38. So when we have all three sides, we do the square root of the semi-perimeter times the semi-perimeter minus each side. Okay? These are not the sides. This is S minus each side, right? Okay. Now, Katie, we're going to do one like you were talking about, because Hero's formula won't work with this triangle. Everybody loves Hero's formula. I do too. But it won't work in this triangle. Why? This is called Hero's formula, yeah. I can't use Hero's formula because I don't have all three sides, right? So Katie, what was that other little special formula you were saying to us? Area can be found by doing what?
1/2, side, sine of included angle.
And by included angle, we mean the one that is right between the two sides. So here are my two sides, 13 and 11. The included angle is the one that's between them. All right, guys, if the 42 were up here, that formula doesn't work. You see the difference? So that angle, if you're going to use this formula, that angle has to be between the two sides that you're using. And then you just type it in. I mean, there's literally no work to this problem. 1/2 times 13 times 11 times sine 42. I got 47.84. Right? All right, well, hang on to that paper. Let's do a few from our notes. And then if we have time, we can come back and do the other side.
We're learning a new lesson right now?
Huh?
We're learning something new right now?
No. I mean, we're finishing up 2-6, or 3, or 5-6. We're just finishing the What formula? Yes, you're memorizing it. Yep. Yep. And again, Clara, when you say memorize the formulas, I don't have the formulas necessarily, just to know how to use it. Yeah. Okay, so we are now in our notes, another area problem. Hey, stop it. Gotta pay attention. We have to find the area of this triangle. Now, I want you to stop a minute, and I want you to think about what we just reviewed. Jaden does not want me to teach you anything new, so I'm not going to.
For real?
So right now, at this moment, you have two ways of finding area. You either have all three sides, and you do Hero's formula, or you have two sides and the included angle, and you do 1/2 side sine.
1/2.
Now, this triangle doesn't fit either one of those.
Oh, then you have two
Okay,
sides.
I gotta have two sides. Now, exactly. If you don't have what you need, then you're gonna, let's say we're gonna find side B. Because if I knew what B was, could I do 1/2 side sine? All right, so how do I find side B? I either go back to my law of sines or my law of cosines. So when I look at the problem, can I figure out this angle? And then I'll have a pair, and then I'll use my law of sines, right? So what's this angle? We are in our notes. On the back of page 42, we're doing 2E, and I'm figuring out what this missing angle is.
69.
69. So now I have my pair, and I will say sine 69 over 16 equals sine 49 over B. Now, my job is to find the area, right? And to find area, I need either all the sides or two sides in the included angle. So that's what I'm shooting for. All right, so here we go. We'll cross multiply and divide. What am I going to divide by here? Sine 69. Is this one where I'm going to have to do second sine?
No.
Nope. So I just type in 16 sine 49 divided by sine 69. Don't forget to close the parentheses after the 49. Did you get 12.93?
Yeah.
That is not the answer to the question. Remember, the directions say find the area. So now I can say area is what? 1/2 12.93 times 16 times sine 62.
Two things in one.
Yep.
Would it have mattered which?
No. So Kennedy is saying, could I have found side A? Remember, I didn't have this one either. You could have used the law of sines to find side A, but then your setup would be 1/2 16A sine 49, because the angle between those two sides is 49.
Oh, so you have to do the angle between.
It has to be the angle between. So it doesn't matter what side you have, but it's got to be the angle between. Okay? All right. Let's look at the next one. It's a word problem. The area of a hexagon inscribed in a circle.
Was the answer 91?
Yeah, you didn't even tell us the answer.
Okay, can you type that in on
I mean,
your
I'm
calculator?
just trying to make sure my answer was correct.
What do you mean by the angle?
0.5 times 12, 12.93 times 16 times sine 62. 91.33.
12.93. So you plug in for the first two. And then after signing it up,
All right, I need everybody looking on page 43 at problem number 1. Page 43, problem number 1. We have a regular hexagon inscribed in a circle. So I want you to draw a circle on your paper.
I was talking triangles and circles.
Stop it, draw a circle on your paper. Now, what does hexagon mean? 6. So I want you to make 6 hash marks around your circle. Just make 6 hash marks. Nobody's grading your picture, so it doesn't have to be perfect. Don't sweat it. Then I want you to connect or put circles here where your hash marks hit the circle. And then I want you to connect those dots with straight lines. So you will have a hexagon inscribed in a circle. Okay, you drew the circle, drew 6 dots around the circle, connected the dots, that's your hexagon. Now it says the radius, and you know what a radius is, start at the center and come out to one of your dots, that's 22. It says that in the problem. Okay, Antoine? Now, would you agree that I could draw in all of the radii and they would all be 22?
Yes.
Yeah.
So I'm going to go ahead and do that. I'm not going to label all of them, but you can if you want. Notice that when I do that, I got a bunch of circles, or a bunch of triangles, right? A bunch of triangles. So let's look at one of them. Let's look at this triangle right here. Now, would you agree all these triangles are the same? I know my picture's not perfect, so they don't look like it, but they're all the same, right? So if I could find the area of that one, that would be the same as the area of all of these. So if I want the area of the whole thing, I'll just take 6 of those, right? Understand my strategy?
Yes.
All right, so I want you to look at that triangle. You already have 2 sides.
1, 2.
Wouldn't it be awesome if you could find this angle? Because if you knew that angle, then you would have 1/2 side, side, sine. Okay, so I want you to think about it. Is that angle the same as this one, and this one, and this one, and this one, and this one? Are they all the same?
Yes.
Yeah.
But if I added them all up, if I took all of those 6 angles and added them up, what would I get?
360.
360. So each one of them must be 60?
Are you small?
Now, I know 60 is one of our special angles, but we don't care. The area of that triangle right there will be 1/2 22 times 22 times sine 60. Because one of our area formulas is 1/2 side, side, sine. So I can find the area of that triangle. So 1/2 times 22 times 22 times sine 60.
209.
209. But wait, don't write that down. That's not the answer to the question. That's this area. So just hit times 6.
1,257.
And that'll give you the answer. So it's 1,257.47 square feet. Remember, on our word problems, we gotta put our unit, and it said the radius was 22 feet.
It's 4.
So, it looked like a really scary problem, but it wasn't. The key was splitting it up into triangles, because you know how to find the area of triangles. Lindsay?
When we got the 209, could we round that up to 58 and then multiply it by 6? That is
No. Don't round it off if you don't need to. So there's no reason to round off that area triangle. So leave it on your calculator, just hit times 6, and then you're gonna have a better answer, okay? All right, next. Now we have the area of a parallelogram. Do you remember what a parallelogram is?
Like on 4 sides?
It's 4 sides, and opposite sides are parallel to each other. So we normally draw them like this. That's a parallelogram. And the sides are 14 and 16. Now remember, opposite sides are congruent, so that would be all the sides then. And the smaller angle is 48. So remember, we got two angles right here, right? This one is the smaller of the two. Would you agree with that? So that's 48. Okay, look at that angle and look at this angle. These two are the same. If I do this, and if I do this, I can't even do that, it's too big. Those are not congruent angles. They would be if it were a rectangle, they would both be 90. But clearly, one of them is smaller than the other, they have to add up to 180. Remember all that stuff you learned in geometry that you thought you'd never need again?
No, I never learned it.
Wouldn't you like cut it in half?
Okay, so this is what we have so far. What Lindsay is saying is, okay, Mrs. Ford, I was paying attention over here. I had this big shape, but to find its area, I split it into triangles. So can I split this into triangles by drawing in a diagonal across here?
Yeah.
And these two triangles are exactly the same. This triangle and this triangle are exactly the same. So if I can find the area of this one, I'll just times it by 2, and that will be the area of the whole thing. Well, can I find the area of that one?
Yeah.
Oh, it's easy. You got what you need, right? How do we do it?
1/2
1/2
times 14
times 14
times 16
times 16
sine 48.
sine 48. Now that is the area of the triangle. Once you get the area of the triangle, you need to double it, so times 2, and that's 166. The total area is 166.46 square centimeters.
Dude, that wouldn't even, like, that triangle wouldn't even work. Is that, oh wait, never mind, I was thinking something else.
Okay. Okay, yeah, because I think it will work. In fact, I know it will work. It's a good triangle. All right, everybody okay with that one? Okay. Now it says, find the length of the longer diagonal in that parallelogram. All right, so let's draw the parallelogram. Again, here's the parallelogram again. We got a 14 and a 16. Now there's two diagonals that I could draw. The one I drew already, which would be this one, and this one. Which one is going to be longer, number 1 or number 2? 2 is going to be longer. So I need to find the length of that diagonal. I'll call it X. Now this isn't area. Okay, this is not area. I'm finding a length. Now, there is one thing about this parallelogram that you have to remember, and I mentioned it a minute ago, but it went by fast. These two are called consecutive interior angles, or same side interior angles. You have parallel lines cut by a transversal. These guys always add up to 180. They're always supplementary. So they told me this one was 48. I have to figure out that the big one then is 180 minus 48. So now I'm over here, this is 132, I figured that out, that's 132. I want you to look at this triangle right here. I'll erase the rest of the picture so it doesn't confuse you. There's your triangle. Do I have a pair?
Yeah.
I do? I don't know this angle, and I don't know this angle.
You have the sides and the angle in between.
Okay, which is perfect if I want area. I don't want area. What I'm trying to do is figure out if I need the law of sines or the law of cosines.
Oh, cosine.
Definitely gonna be a law of cosines problem, right?
Oh.
Cosines.
Wouldn't that other, like, the other corner just be half 48?
No, the diagonals of a parallelogram do not bisect. The diagonals of a rhombus bisect, but not a parallelogram in general. So no. Common mistake. That's why I didn't even talk about it. I erased that line, get it out of there. This angle is a supplement of that one. Always. All right, so I'm going to do my law of cosines. So I got cosine 132 out here.
X squared.
And over here is going to be x squared. And then what's all the stuff in the middle? Quiz practice here. What's all the stuff in the middle?
14 squared.
14 squared.
Plus 16 squared.
Plus 16 squared.
Minus 2.
2. 14, 16.
Yep.
And see your variable sitting over here all by itself? That's good news. Type it in. What do you think is the biggest mistake that kids make or people make when they're using the law of cosines? Exactly. They forget to square root it. Did you get 751 when you typed it all in? We got to square root it. So the long diagonal is 27.42 centimeters. If you are looking for a side, you use the law of sines and law of cosines, okay? If you're looking for area, you use one of your area things.
Did you just square 751?
Huh?
Did you just square 751?
I square rooted it. Whatever I got when I typed all that in was x squared, so I square rooted it. All right, last problem. Uh-oh, a pentagon inscribed in a circle. So draw your circle. This time, how many dots are we putting around it?
5.
5, it's a pentagon. So spread them out as best you can, but again, nobody's grading your picture, so it doesn't matter. There's my pentagon, right? And I know that the radius is 28 inches. Okay, so think about what we did last time.
You draw it on the triangle.
Doing all the triangles to remind myself that they're triangles, first of all, and I have 5 of them, and all of these lines I just drew in are 28s. Now, I really don't need to spend a ton of time looking at all 5 triangles. They're all the same. So I'm going to focus on one of them. What do I need to find the area of this? What would be really something easy to find so that I can find the area of that? This angle right here, right? That would be the best thing to know, because that would be the 2 sides and the angle in between them. Now, how many are there this time? 5. And they're all equal. And what do they all add up to? 360. Look, watch my finger. Isn't it going around in a circle? So they add up to 360. So that means each one of them is 72 degrees. So now you can find the area of the triangle. The triangle will be 1/2. What's our formula? 1/2 side, side, sine of included angle. So 1/2 times 28 times 28 times sine 72. Is that right? Now, I got 372. Am I done?
No.
No. What do I have to do?
Multiply.
Multiply by 5. So I get the total area is 1,864.07 inches square inches. Okay? All right, quickly, let's turn over our practice quiz and let's practice a couple more.
Side two.
Yeah, side two, which is, I want you to understand, your practice quiz is one side. It looks just like side one or just like side two. This is just double practice. I love math too. Stop it. Here we go. Your job on side two is to find side A.
Is this one we're writing down?
Huh?
Is this one we're just writing down?
What do you mean? We're just writing
Like,
it
is
down?
this, we're just writing
Yeah,
this
that's
down?
right, this one.
Yeah, we're gonna find side A.
It's on the back.
It's on the back. Side two of our practice quiz.
Yeah, that's what I was asking.
And we're going to find side A. Now, when we find a side, we use sines or cosines. Okay, the law of sines or law of cosines. What's appropriate here? Cosines. So the only angle I have is 28. So out here on this end, I'm putting a 28. Right? And what does that mean is all the way at the other end?
A squared.
A squared. And then in the middle, 13 squared plus 17 squared minus 2 times 13 times 17. I just type it in and square root it. When you square rooted, did you get 8.23? If you wrote 67 down as your answer, you forgot to square root. Remember, the law of cosines, that's a square, so you have to square root it. All right, we don't have to do both of these, but let's set them up. So 2A, what will the setup be? Hero's formula. So we'll find the perimeter. What's our perimeter? 38. Half of 38 is 19. So 19. And then we'll do 19 minus each side in any order. So 19 minus 10, 19 minus 12, 19 minus 16. And that would be the setup. All right. What about B? What's the setup for B? 1/2 10 times 17 times sine 83. Because I know that area is 1/2 side times sine.